Okay, sorry, I thought the last video would cover all the questions and then my phone ran out of space. So the last video now for paper 6, June 2018 is this one, and this will go through questions 17 to 19. So we have a function machine. We know the output is x. So basically what's coming out of here is x. We've got to write an expression in terms of x for the input. So whenever you've got to go backwards to get the input, you've got to do the opposite to what it says. So where it says times by 5, the opposite would be to divide by 5. So I'm just going to write that as x divided by 5, x over 5. Then after that, they've put to plus 14, so the opposite would be to minus 14. So it's important to make sure you write that separately. Sometimes it can be very tempting to like put it at the top like that, but actually you need to divide it by 5 first and then minus the 14. So part B, a number k is put into function A and the output is also k. Find the value of k. So when I put k into here, I get k also coming out. So if we think what happens to k when we put this through, so k plus 14, well that would be k plus 14. Then I would have to times that by 5. So I would get 5k plus 14 times 5. So that is going to give me 70. And I know then that I also get k when I come out. So basically that equals k. So we have got to solve that equation to work out then what k is. So I'm going to minus k from both sides. So I'm going to get 4k plus 70 equals 0. Then I would minus the 70. So 4k equals minus 70. And then I would divide by 4. So minus 70 divided by 4 is going to be minus 17.5. So k is minus 17.5. Question 18. So the chart is to show the, I'm not sure what the question is. So plastic cells paint in standard tins, large tins. The standard tin covers 40 meters squared and the large tin covers 60 meters squared. Okay. So explain why the chart is misleading. Well, it's essentially a bar chart, but the bars are different widths. So I would just, that's all it needs, is just one mark. So the bars are different widths. Part B, so the standard tin and the large tin are mathematically similar. The volume of the large tin is 50% more than the volume of the standard tin. So you've got to think, if you're trying to increase the volume of something by 50%, what would you times that by? So the multiplier would be 1.5, because if you're trying to make it 50% more, that would be 150%, which is 1.5. So we know that if you've got a smaller tin, we're timesing the volume by 1.5 to get the volume of the bigger tin. So that means the volume scale factor is 1.5. Whenever you see the words here, I should have said this at the start, whenever you see the words mathematically similar or just similar, it's going to be to do with scale factors. So whenever you do that, always try and think, what scale factor do you know? What scale factor are we trying to work out? So we're trying to calculate the radius. Well, is the radius a length, an area, or a volume? Well, the radius is just a length. So I need to work out the length scale factor. So if I know the volume one, I just need to cube root that to get the length one. So the cube root of 1.5. So that is, I'm going to write the whole thing down because I haven't finished the question yet. So I get that. So that means I'm timesing the smaller radius by this to get the bigger radius. So the radius of the standard tin, which is the smaller one, is 10 centimeters. So basically I just need to times this length scale factor by 10 to get the radius of the bigger one. So that is going to be 11 point, it doesn't say how to round it, so I'm going to say 11.4 centimeters when I times that by 10. And then the final question is algebraic fractions. So I just need to simplify that. So to do that, I need to try and simplify the top. Not simplify it, factorise the top, factorise the bottom, and then look for what brackets we can cancel out in both. So I'm going to begin with the 2x squared plus 13x plus 20. Now you may have been taught to factorise in a slightly different way. I think most groups now do it this way, but so we do the 2 times 20 is 40. You want numbers that multiply to get 40 that you can make 13 from. So it's going to be to do with 8 and 5. So I'm going to put this into double brackets. We put whatever's here without the squared at the beginning of each bracket. And to make 13, it's nice and easy. It's just 8 plus 5. So I just put plus 8 plus 5. Everything is positive. Check to see, can you simplify one of these brackets? Well, this one we can divide by 2. This one I can't do anything with, so that's going to stay the same. So that's going to be the top of the fraction. I'm now going to have a look at the 2x squared plus x minus 10. So 2 times 10 is 20. So I'm trying to think of numbers that multiply to get 20 that I can make 1. That is 1x there in the middle. So it's going to be to do with 5 and 4. To make 1, I would have to do 5 minus 4. So at the beginning of each bracket, this time I'm going to put 2x again. I need to make sure I do 5 minus 4, so it's going to be plus 5 minus 4. This one I can't do anything with, but this one I can divide by 2 to get that. So I'm going to get this on the top, so x plus 4, 2x plus 5, over, and then this was the bottom part, wasn't it? This was on the bottom, so I'm going to put that underneath, so 2x plus 5, x minus 2. Now a sure way that you've done is correct is if you have the same bracket on the top and the bottom. If you don't, chances are something's gone wrong. So you can see here I've got 2x plus 5, 2x plus 5. That means they will cancel out because you're doing that divided by that. So you just get 1, so it just cancels out. And then you just write what you're left with. So x plus 4 over x minus 2.